electrical components, no? Kung saan pag i-focus natin yung capacitor and iba pang electronic components. Okay? So, simulan natin. Okay? So, ito po yung itsura ng capacitor, no? So, yung capacitor po, isa po yung tinatawag natin na dielectric. Okay? So, meaning, so it is somewhat a conductor, no? In a certain, if it is applied by a voltage. Okay? So, yung capacitor is measured by capacitance. So, capacitance is by definition is the property or how well a capacitor can store electrical energy. So, gaano ka ano ka ah, kaganda, no? Or yung kapasidad ng ating capacitor para mag-store ng electricity. So, to solve for that one, so we have this formula. So, C is equals to Q over E, wherein your Q is charge. Ang itong charge is coulomb. Yung E is in volts at yung C is your capacitance, which is in farad. Okay, so we have here isang halimbawa, no? So, an electrolytic capacitor is rated at 60 farad. It is connected to a 220 volt source. So, what is the amount of charge in the capacitor? So, yung hinahanap po dito is yung charge. Okay, solution. So, we have, so our given, una is the capacitance, which is 60 farad. Then the voltage is equal to 220 volts. So, yung hinahanap po is yung charge. So, capacitance is equals to charge divided by the voltage. So, meron po tayong 60 farad. Ano pala? Yung hanap natin ito is yung charge pala. So, ano natin ito? Erase muna natin ito. So, let's solve for the charge. Ilip na sa kabila. So, we have charge is equals to the capacitance times the voltage. No? Substituting. So, we have charge. So, our capacitance is 60 farad. Habang yung ating voltage is 220 volts. Okay? So, using our calculator. Yan. So, using our calculator here. Wala yung calculator, hindi makita sa screen. Okay, yan. Yan. So, we have 60 farad times 220. This is equal to 13,200 coulomb. Okay? So, we have, so our answer is, so the charge is equal to 13,200 coulomb. So, the correct answer will be letter A. Okay, yan. Okay, next. So, a capacitor stores 0.24 coulombs at 10 volts. So, its capacitance is blank. Okay, so kung gusto nyo pong mag-solve with me, so you could give your answer by chatting on our chat box or our comment section. Okay, so from this problem, solution. So, we have the formula C is equals to Q over E, no? So, sa given, we have our charge, no? Yung naka-column that is 0.24 column. At yung ating voltage naman is equal to 10 volts. So, substituting. So, we have, so column which is 0.24. Yun ang charge natin. Divided by the voltage which is 10 volts. Okay? So, using our calculator. Yan. So, we have 0.24 divided by 10. Okay, so that is equal to 0.024. So, 0.024 coulomb. So, the correct answer, hindi pala coulomb but farad. Capacitance kasi ginanap natin. Okay, yan. Okay, so we have farad, no? So, the correct answer for this one is letter So letter A yung tamang sagot dito. Okay? Then we have the physical construction of a capacitor. So yung rating ng capacitor is dependent on the amount of the charge it could help, no? Yan. Ibigay mo natin yung kulay nito. Then we have the voltage handling capacity. Kung ano yung kayang voltage na i-handle ng ating capacitor. Then the insulating material. Kung ano yung nasa gitna. No? It could be mica, ceramic, or aluminum. Okay? So the capacity to hold no charge, no, yung mismong capacitance ng ating capacitor depends on these three properties. The surface area of the conductive plate, no? Surface area nito. Yan. Yung surface area niyan, dalawang yan. Then space between the plate, no, yung spacing. So the narrower the spacing, so the higher the the field, no, or the electric charge that it could store. Then the materials between the plate. Kung anong klase yung materials na doon sa ating mga plates. Okay. Then we have other properties of capacitor. So dielectric strength, so that is defined as the electrical strength of an insulating material. So if sufficiently strong electric field that field the insulating properties of an insulator breaks down, allowing the flow of charge. So kapag sobrang strong ng ating electric field, no, yung insulating na property ng ating insulator will break down. Therefore, our insulator na will become a conductor, no? Nag-allow na siya the flow of charge. Then dielectric breakdown, so that is the failure of our insulating material to prevent the flow of current. So ibig sabihin ito, no, hindi na kinaya ng dielectric strength niya. So nagkaroon na tayo ng dielectric breakdown, no, in which our insulating material is now allowing the flow of current, no, under applied electric stress or applied voltage. Then dissipation factor of a capacitor is the power loss when AC is applied to the capacitor. So if yung dissipation factor, if our capacitor is supplied, no, by a DC or an AC voltage, no, AC supply, so nakakaroon siya ng power loss. So the lower the dissipation factor, the much better the capacitor is. Okay, next. Okay, we have here the types of capacitor. The very first one is electrolytic. So it could be it could be tantalum or aluminum with an oxide dielectric layer. So the second electrode is liquid electrolyte. No? So electrolytic capacitor offer high capacitance. So ito yung mga advantage. High capacitance, but it has a poor tolerances. No? High instability. Gradual loss of capacitance, especially when subjected to heat and high leakage current. No? Then film capacitors, so they're also known as plastic film capacitors, film dielectric capacitors, or polymer film, no, also known as film caps. So they are usually used, no, for they are usually used for AC and DC application, no. So film capacitors specifically physically, no, larger. So wala yung ano ko dito, yan. Physically larger and more expensive compared than aluminum, but have much higher surge and pulse load capabilities. So they are not polarized. So meaning, pwede nating pagbalik rin ang kailang mga terminals. They can be used in AC voltage without DC bias, and they have much more stable electrical parameters. So polypropylene capacitors, film capacitors have relatively little temperature dependence. So meaning hindi na siya doon naapektuhan ng temperature, no, ang kaniyang capacitance, and lower na dissipation factor. Ceramic capacitors, they are fixed capacitor, no, meaning hindi nababago yung kanilang mga capacitance with the ceramic material which acts as the dielectric. So it is constructed of two or more alternating layers of ceramic and a metal layer acting as the electrode. The composition of the ceramic material defines the electrical behavior and therefore the application. So meron tayong dalawang klase ng ceramic capacitor. Class 1 are those capacitors, ceramic capacitors that offer high stability, high stability and low losses. So this is for resonant circuit applications, Habang ang class 2 naman offers high volumetric efficiency and for vapor, bypass, and coupling applications. Okay. So ito po yung mga table no of capacitors no depending on the type, class, and the material at kung ano yung kanilang dissipation factor no. So you could screenshot this one no so that you will have a reference. Okay. So for making a capacitor, it is better to select a dielectric having blank, low permittivity, high permittivity, permittivity same as that of air, permittivity slightly more than of air. No? So the correct answer for this one is letter. No? So the correct answer for this one is letter B. Yan. Okay. So the dissipation factor of a good dielectric is the order of. So kaya sabi ko kanina, kapag mas mababa, mas okay ang dissipation factor. No? So mas okay yun na siya na capacitor. Okay, so correct answer for this one is letter A. For which of the following parameter variations the capacitance of the capacitor remains unaffected? Okay, so the distance between plate, the area, the nature, or letter D, the thickness of the plates. So kanina, so ang sinabi dun sa ating previous slide, that is the distance, the area, and the nature or the klase ng dielectric. So ang correct answer for this one, hindi kasama or hindi nakaka-affect, will be the thickness of the plates. Okay, so we have behavior of a dielectric on a DC circuit or a DC source. Okay, so when connected no, to a DC source, okay, so the capacitor charges and holds the charge in as the DC voltage is applied. So the capacitor essentially blocks DC current from passing. Meaning hindi nakakatagos yung ating DC current kapag our capacitor is connected to DC source. Okay? So the capacitor and capacitance value. So the unit of capacitance is farad, no? So a farad is a huge amount of capacitance. So meaning almost all of our capacitors are rated on a fraction of a farad. So we have micro, nano, and pico, sometimes milli, but usually milli is for power engineering or power systems application. So we have here the micro 10 to the power negative 6, no? Ito po kanya symbol. Then the nano, so 10 to the power negative 9, and pico 10 to the power of negative 12. Then we have the energy stored in a capacitor. So that is given with the formula. So energy is equals to 1/2 times the capacitance times the square of the energy. Or in not the energy but voltage, the square of the voltage. Now wherein our energy, the unit will be in joule, the capacitance in farad, and the voltage in volts. Okay. So we have your example. So how many joules is stored in a 20 farad at 60 volts? Okay, so solution. Okay, so ang given po natin, the capacitance is 20 farad. Then the voltage is 60 volts. So ang hinahanap po is the energy on our capacitor. So we have, so energy is equals to 1/2 C E squared. No? So we have 1/2 times the capacitance, which is 20 farad, times the voltage, which is 60 volts, no, squared. So using our calculator, so we have 20, ano pala, 1/2, so 0.5 yan, 0.5 times 20 times 60 squared. Okay? So the correct answer is 36,000 joule. So our work is equal to 36,000 joule. No? So ito yung ating tamang sagot. Okay? Next. So we have, if a capacitor can store 300 joule at 30 volts, so what is the capacitance? So ginhana naman dito ngayon is a capacitance. Okay, solution. So we have our voltage, which is equal to 30 volts. Then our energy, which is equal to 300 joules. So the formula, energy is equals to 1 half CE squared. So hinahanap dito is the capacitance. So ilipat natin itong yung 1 half at ito sa kabila. So ito magiging 2, no? Tapos energy, divide E squared. So we have 2 times the energy, which is 300 joule, over our voltage, which is 30 volt squared. Yan. So using our calculator, so we have 2 times 300 divide 30 squared. Okay, so that is equals to 2/3 or 0.67. No? Ayan. So we have equal to 0.67. So this is farad. Okay, so an electrolytic capacitor can be used for, so it can be used for DC and AC applications. So the capacitance of capacitor is not affected by blank. So katulad to ng question kanina. So the thickness, no, of the plate. So when 4 volts of EMF is applied across a 1 farad capacitor, it will store energy of blank. Okay, so solution. Yan. Okay, so we have energy pala. Energy is equals to 1 half CE squared, no? Yan. So we have 1 half. Our capacitance is 1 farad. And our voltage is 4 volts squared. Okay? So we have 16, no? 4 squared natin is 16 times 1 divided by 2. So the correct answer for this one is 8 joules, no? So the correct answer is letter D. Okay, then we have other electrical or electronic components. We have a diode. It's a semiconductor that is essentially acts as a one-way switch, no? So it allows current to flow in one direction and restricts, no, the current to flow in the opposite direction. So yung forward at reverse bias na application ng ating diode. A resistor is a miniature semiconductor that regulates or controls current or voltage flow in addition to amplifying and generating these electrical signals and acting as a switch or gain for them. So, ang resistor, meron tayong sinasabi dito na amplification. Aside from acting as a switch, so it is now also amplifying the electrical signals. An IC circuit, sometimes called as a chip or microchip or microelectronic circuit, is a semiconductor wafer. So it's a form of a wafer in which thousands or millions of tiny resistors, capacitors, diodes, and resistors are configured. So meaning, ang IC is a circuit, no, a miniature circuit which is made, no, to function a certain task, no, or certain way, no, because it is made up of capacitors, resistors, and diodes. Then a vacuum tube, also called as a valve in British English, is an electronic device used in many older models of radio, television sets, and amplifiers to control electric current flow. So the cathode is seated as in a light bulb, so it will emit electrons. So basically, the vacuum tube is the very first very first, no, electronic na component. Okay, so semiconductor terms, we have forward biasing. So meaning, kapag ang ating diode is naka-forward bias, meaning our diode is in on. Reverse bias, so the circuit is reverse, no? So meaning the diode is turned off. So doping is adding, no? Adding impurities, no, to our semiconductor so that it will enhance, no, its electrical, optical, and structural properties. Then hole is the absence, no? Yung place na kung saan sa orbit ng ating atom is nawala yung electron. So that is what we call as hole. Emitter, no? So yan yung part ng transistor that is heavily doped, no? Yung base naman, so that is the size of the base region is extremely small, so meaning it is not doped, no? So it is less than the emitter, no? Then the collector is moderately doped, so gitna, no? And the size of the collector region is slightly more than the emitter region, but also the charge carriers coming from the emitter recombine at the base and heat is released in this process. Then you have amplification. So the process of increasing the magnitude of a signal, no, generally using by an amplifier. Then power electronics is the application of electronics to control and the conversion of electrical power. Then we have active components. No? So active components of circuits are those components that requires a source of energy, typically formed in the form of the current, in order to perform their specific function. While passive components are those that do not require any external source for the operation and are capable of storing energy in the form of voltage or current in the circuit. No? So dito natin yung chart. So our active component will be our transistor, diode, LED, photodiode, IC, op-amps, the 7-segment display or the BCD, no? Then we have the battery, while the passive naman is the resistor, the LDR, the thermistor, capacitor, inductor, switch, variable resistors, and transformers. Okay, no? So that will be all, no, for this discussion. So I hope po may natutunan kayo sa ating session tonight.